Hey, Math 20-2. Today we're going to look at the quadratic formula. All right. So let's do a quick review of what we've learned so far. Find the roots of the following equation by inspection. All right. Inspection really just means simple factoring. So let's factor the left side of this equation. Only way to get to x squared is to multiply by two brackets with an x in the front of each bracket. Remember, the whole thing is going to equal 0. And what two numbers have a sum of 7, a product of negative 18. Those two numbers are positive 9 and negative 2. So once I've factored this, then I can use my zero product law and set each variable factor equal to 0. So x plus 9 can equal 0, or x minus 2 can equal 0. And then we solve these simple equations, x equals negative 9, or x equals positive 2. And there are our solutions. All right. Part B, find the roots of the equation. 6x squared minus x minus 12 equals 0 using decomposition. So we're still going to factor, but now we have to decompose the left side of this equation. So again, we still ask ourselves, what terms have a sum of the middle term, negative 1, but a product of 6 times negative 12, which is negative 72. So what the numbers add to negative 1, multiply to negative 72. And once we know what those two numbers are, we're going to decompose this in negative 1x. So it's going to be minus 9x plus 8x minus 12. So negative 9 plus 8 is the same as negative 1x. And negative 9 times negative 8 is negative 72. Remember, this equation equals 0. Now we factor by grouping. Common factor here of the first two terms is a 3x. We're left with 2x minus 3. Common factor of the last two terms is a positive 4. We're left with 2x minus 3. Whole thing equals 0. I now have a common binomial factor of 2x minus 3, so I factor that binomial out. I'm left with 3x plus 4 as my second factor. And just like the first question, I can now set each of these variable factors equal to 0 using my zero product law and solve the resulting simple equations. So 2x minus 3 equals 0. I'm going to add 3 to both sides and divide by 2. 3x plus 4 equals 0. I'm going to subtract 4 from both sides and divide by 3. There are your solutions. X is 3/2, x is negative 4/3. All right. Is it possible to solve the quadratic equation by either of the above methods? Explain. So what we'd have to do is solve this equation by factoring. So we would ask ourselves, what two numbers have a sum of negative 8 and a product of 2 times 5, which is 10? So if I list all things and multiply to 10, 1 times 10, 2 times 5. Those are the only things that multiply to 10. 1 plus 10 or 1 minus 10 will give me 11 or 9. So that's not going to give me negative 8. 2 and 5, if I add or subtract those, I'm going to get 7 or 3. That's not going to give me negative 8. So we cannot factor the left side of this equation. So we can't factor the left side of this equation. Therefore, we can't solve it by inspection or by decomposition. So if that's the case, how would I solve it? Well, we could solve it by graphing. All right, we could solve by graphing. All right, so if I wanted to, I could solve this equation by graphing. 2x squared minus 8x plus 5. So go to your graphing calculator and go to y equals 2x squared minus 8x plus 5 minus 8x plus 5. So if I graph the corresponding function and find the x-intercepts, I would solve this equation. So I can calculate the zeros, get left of that first x-intercept, grade on left of it, get right of it, and guess, don't have to make a guess, 0.775255513. So we'll say x is 0.78. So if I were to solve this by graphing, I would draw the quadratic. That's the graph of 2x squared minus 8x plus 5 equals y. And this first point, first x-intercept would be 0.78. And let's find the second x-intercept. So I can calculate the 0, get left of it, get rid of that second one, and looks like it's 3.22. So we could say x equals approximately 0.78 and 3.22. So they're not exact values. We got to round these. When we do it graphically, we can't get an exact value. All right. The review on the previous page, we were unable to solve the equation by inspection or decomposition. We could have solved it by graphing, which we did. Another algebraic method we could use is something called the quadratic formula. So this formula below is called the quadratic formula. When the equation is in this form, ax squared plus bx plus c equals 0, then the coefficient of x squared is a, that goes there. The coefficient of the x term is b, that goes here. And the coefficient of the constant term, or the constant term itself, is c. So we're just going to take those values and substitute them into this quadratic formula, and they'll give us the solutions for x in the equation. So Gavin's using the quadratic formula to verify the roots of the equations on the previous page. Example A has been completed for us. Follow his method in A to complete part B. All right, so we got answers for part B, if you recall. Our answers for this equation were x equals, if we look at part B, we had x equals 3/2 and negative 4/3. So x equals 3/2 and negative 4/3. So we should come up with the same values using the quadratic formula. Given this equation, a is the coefficient of the x squared term, so 6. B is the coefficient of the x term, so that's negative 1. And c is the constant term, that's negative 12. So we just have to plug these into this quadratic formula, and they'll give us the values for x that satisfy the equation. So negative b, that should be the formula if they've got the negative sign. Negative b, so the negative of negative 1 plus or minus the square root of b squared minus 4 times a times c all over 2a. So we just substitute those values in and simplify that expression now. All right. So x equals minus negative 1 is like saying 1 plus or minus the square root of negative 1 squared is 1. Negative 4 times 6 times negative 12. Negative 4 times 6 times negative 12 is 288. So we would say negative 1 plus 288 all over 2 times 6, which is 12. All right, so simplify the radical, 1 plus or minus the square root of 289 all over 12. So you go to your calculator, find out the square root of 289 is 17. So x equals 1 plus or minus 17 all over 12. So there are our two answers. X could equal 1 plus 17, which is 18 over 12, or x could equal 1 minus 17, which is 16 over 12. So if we simplify these two fractions, 18 over 12, that's the same as 3/2. And sorry, 1 minus 17 is negative 16. Negative 16 over 12 is a negative 4/3. So there are two answers, the same as we had by factoring. So the quadratic formula, if we do it properly, should give us the same solutions. All right. Since the quadratic equation 2x squared minus x plus 5 can't be factored by inspection or decomposition, means that the roots of the equation, if they exist, must be irrational numbers. The roots of such an equation can be given using exact values involving radicals, or as approximations to a given number of decimal places. So if I want the answer as an exact value to this equation, I have to use my quadratic formula. We graphed it, and we found the x-intercepts, and we found out that x is 0.78. And what was the other one we had? 0.78 and 3.22. So using our graphing calculator, we found out x is 0.78 and 3.22. But those are approximations. They are not exact values. So if I want the answer as an exact value, I must use the quadratic formula. All right. Graphing will only give me the answer maybe the nearest tenth or hundredth or thousandth. I have to round it. So let's figure out what the exact value of these solutions are for this quadratic equation. So we know the formula. I know my A value is 2, my B value is negative 8, and my C value is 5. So using those values, let's plug into our quadratic formula. X equals negative B, so minus negative 8, plus or minus the square root of B squared minus 4 times A times C, all divided by 2A. So that's our quadratic formula. Substitute in, and now let's simplify. Minus negative 8 is like saying positive 8. Plus or minus the square root of negative 8 squared is 64. Negative 4 times 2 times 5 is a negative 40. All over 2 times 5, which is 10. So the roots x equals 8 plus or minus the square root of 24 all over 10. Now I have to simplify that radical 24, and luckily we've simplified radicals, so I know that 24 can be written as 4 times 6. All right. So if I simplify that radical, I get 8 plus or minus the square root of 4 is 2. There is no square root of 6, all over 10. And 8, 2, and 10 are all divisible by 2. I don't worry about the root 6, just the coefficient number in front of the radical. So in simplest form, divide everything by 2. This is going to be 4 plus or minus root 6 all over 5. So that's the exact values. Now if we wanted to, we could say x equals 4 plus root 6 divided by 5, and x equals 4 minus root 6 divided by 5. Those are the two roots, but we can leave it like this: x equals 4 plus or minus root 6 all over 5. That's simplest radical form. These are the two exact values. Let's see if those give us the same answers we had by graphing and finding the x-intercepts, 0.78 and 3.22. So let's go to our calculators and try this and see if we get 0.78 and 3.22. So 4 plus the square root of 6 divided by 2. That gives us 3.22. And if I go second entry, I get the thing we just, and change that plus sign to a minus sign. 4 minus root 6 divided by 2 gives us 0.78. All right, so those are the exact values. 3.22 and 0.78 are the rounded values to the nearest hundredth. Example 3. Explain how you can determine the zeros of a function using the quadratic formula. Explain how you can determine the zeros of a function using the quadratic formula. Well, the zeros of the function, are the same as the roots or solutions of an equation. And the quadratic formula gives us the roots of the equation. So we consider the function f of x was 4x squared minus 12x plus 9. Use the quadratic formula to determine the zeros of the function. What do we notice? All right, well, if I want to find the zeros of the function, that means 0 equals 4x squared minus 12x plus 9. That gives us a quadratic equation. Once I have a quadratic equation, I can use the quadratic formula. So in this case, a is 4, b is negative 12, and c is 9. So let's plug those into our quadratic formula. All right, so substitute into our quadratic formula, x equals negative b, negative 12, plus or minus the square root of b squared, minus 4 times a times c, all over 2a. And so we simplify now. Minus negative 12 is like saying 12, plus or minus the square root of negative 12 squared is 144, minus 4 times 4 is 16, times 9, which is also 144, all over 2 times 4, which is 8. So we get x equals 12 plus or minus root 0, all over 8, or x just equals 12/8, or in lowest terms, 12/8 is the same as 3/2. So what do we notice? We notice that the solution to this quadratic equation, 3/2, so you notice x equals 3/2. There's only one solution for x. That means when I graph the function, there's 1, there's 2. It's only going to have one x-intercept at 1.5. Right, so it's going to come down and touch the graph exactly at 1.5. Going to cross the y-axis at 9. The y-intercept is 9. So there's the graph of the function f at x. When the radical becomes 0, we've got two solutions that happen to be the same, 3/2. All right, let's look at part C. Consider the function g at x is 2x squared minus 5x plus 10. Explain what happens when you try to determine the zeros of the function using the quadratic formula. So let's try it. All right. A would equal 2, b would equal negative 5, and c would equal 10. Let's substitute that into the quadratic formula. X equals negative b. So minus negative 5 plus or minus the square root of negative b squared minus 4 times a times c, all over 2a. So we get x equals minus negative 5 is like saying 5, plus or minus the square root. Negative 5 squared is 25, minus 8 times 10 is 80, all over 4. So we get x equals 5 plus or minus the square root of negative 55, all over 4. Well, right here, negative 55, we can't have a negative underneath the radical sign. That's an unreal number. So we'd say there are no solutions or no roots to this equation. What does it mean for the graph? If I was drawing the graph of this function, it means the graph's going to approach the x-axis, but it's never going to touch it. All right. So I know the y-intercept should be 10, and I know the graph opens up. So the graph's going to approach the x-axis, but never touch it. So there are no real roots. There are no solutions because I've got a negative sign underneath the radical sign. This function, f at x, never crosses or touches the x-axis, so there are no solutions. All right, that's what it looks like on the quadratic equation if I've got a negative sign inside the radical. So in the previous example, we've shown that a quadratic function may have 2 zeros, 1 zero, or no zeros. This means the graph of a quadratic function will have 2 x-intercepts, 1 x-intercept, or no x-intercepts. And a quadratic equation may have 2 roots, 1 root, or no roots. The quadratic formula can be used to determine the roots of a quad equation. the zeros of a quad function, or the x-intercepts of the graph. In each case, the quadratic formula can only be used if the equation is in this form. So it must be set equal to 0. All right. You guys have your assignment. Numbers 1 through 10. Away you go.